Today's lesson is a review of equivalent fractions before we get into really working with equivalent fractions. Today and tomorrow, today will be a review on what equivalent fractions are. You're going to look at two fractions, you're going to decide, are they equivalent? Tomorrow's lesson will be modeling how to make your own equivalent fractions. They give you a fraction, you use models to figure out what another equivalent fraction is. Friday's lesson, you'll be making your own equivalent fractions using multiplication or division. So, today's just a review of what equivalent fractions are. Equivalent fractions show the same amount but have different numerators and denominators. So that means the two fractions, just by looking at the numbers, they look different. But when you model the two fractions, you'll see that they represent the exact same size and shape. What that means is, here we have two equivalent shapes. Do you see? We have this square that's broken into 4 pieces. 2 of those pieces are shaded. Then we have this square. If you look on your paper instead of mine, you can actually see where they're broken up. This one you can't see the difference between the shading and the lines, but if you look at yours, you can see it. So do you see how on this one right here, you can see the black lines that show 4 different pieces? And then on this one right here, you see the black line that represent 2 pieces, but only one is shaded. But we can see that it's still the exact same amount and shape that is shaded. Now what they mean by shape is we go over here. We have 2 different shapes. We have a square and a rectangle. Now for both of them, the left side is shaded. But is this the same amount? Is this the same amount of shading? Class?
No.
No, this one, because this shape is bigger, has more shaded. So that means these are not equivalent. Even though the same side is shaded on both, they are not the same amount or shape. Then, if we look at the fraction tiles, we have 1/2 shaded, or we have a 1/2 fraction tile, and we can say that it's exactly the same size and shape as 2 1/4 tiles. Do you see that? But over here, we have a 1/2 fraction tile, and then 2 1/3 fraction tiles. Are those the same shape and size? No, the 2 1/3 are bigger than 1/2, so they are not equivalent. Now we go to number lines. We see 2 number lines. The first number line is broken into 2 pieces, and they have 1/2 plotted. But below it, we have a number line that is broken into 4 pieces. 1, 2, 3, 4. Remember, do we count the tick marks when we're doing fraction number lines? No, we count the spaces between. 1, 2, 3, 4, and 2/4 is plotted. They are at the exact same spot on the number line, so they are equivalent. But then, if we go to these number lines, our first one is still broken into 2 pieces, and 1/2 is plotted. But our bottom line is broken into 1, 2, and our bottom number line is still broken into 4 pieces, but instead, 1/4 is plotted. Are they in the same place? Can you draw an invisible line, or an invisible straight line, and meet both of them? No. They don't meet. So they are not equivalent. What is the base word of equivalent? What's the base word of equivalent? Carla?
Equal.
Equal. Remember, base words don't always have every single letter. But you can see that EQU is the same letters that equal starts with. Now that's not always the case, but in this case, equivalent it is. Equivalent is an adjective, meaning that two things are equal. So today we're going to be working on this. We're going to be working on recognizing, by looking, are two fractions equal? We're going to be using shape models, fraction tiles, and number lines. Now let me tell you, when we are trying to find if two fractions are equal on our own, we do not draw number lines to test. Because are we able to draw number lines so that they are exactly perfect and they definitely match up the right time? No, because I could draw two number lines. And I could say, oh, those are equal. But is that true? No. That's why we don't draw our own number lines when we're working with fractions. Anything else, when we only have to draw one number line, we can do that. But if we're trying to compare numbers on a number line by looking at where they are, we do not draw number lines because we can't draw them perfectly correctly so that we can make sure. Now, if they're already printed for you, then yes, you will use a number line. But only if it's already printed for you. You are not going to create your own number line to compare fractions or numbers. Do you understand? Okay, helper number 1. Please sanitize, erase, sanitize. And let's see, Michaela's not here. Kingston, please read the sentences below the title. Loud so we can all hear you and follow along.
Fractions that name the same part of the whole are equivalent fractions. Equivalent fractions are equal and represent the same size.
So, we know the base word of equivalent is equal. That's telling us that two fractions, remember like our anchor chart said, with a different numerator and denominator, are equal because they show the same part of a whole. So we saw with our fraction tiles that 1/2 and 2/4 were equivalent fractions because they showed the same amount, the same part of a whole. That's what we're going to be working with today. Sorry. I should have just shown them. So everybody, be looking at example 1. Go ahead and have your finger or pencil ready because as soon as I get back up there, I'm going to ask everyone to put their finger or pencil on example 1. Thank you to those of you who took that opportunity to get ready. Those of you who did not, we wouldn't have had to wait, but now we are. Okay, read in your head while I read out loud. Remember, every period we're going to imagine what that looks like. Noah has 1/2 of a fruit pizza. Okay, I'm imagining a fruit pizza. It looks like this, but half of it is gone. So like right down the middle. It's cut right down the middle, and one side is gone. How could Noah cut the pizza into smaller, equal-sized pieces and still have half of the whole pizza? So what we're doing is we are taking half of that fruit pizza, and we're figuring out how can we cut it into equal pieces, because obviously someone's not going to eat this whole half of pizza. It's big. That's not fair. There's lots of people. The whole family wants a piece. So how could we cut it so that each piece is exactly the same size? No one gets mad that somebody got a bigger piece than them, but we still have half the pizza. Nobody sneaks a little bit off. So in our example, they have fraction tiles. So here's our whole, one whole fraction tile. Tomorrow, you'll get to use your own. Today, they're mostly going to be drawn for you. But we know, does he have a whole fruit pizza? No. He has half of a fruit pizza. So they took their 1/2 fraction tile to compare it to the whole. Because we want to know, we want to make sure that our other fractions take up the same amount of the whole. So this 1/2 takes up half of the whole. Yeah, that's why it's called 1/2. Well, let's see what other fraction tiles we can use to also make up half of the whole. Noah used 1/4 fraction tiles, and he just started moving them up. He started moving them until he got the same amount of 1/4 tiles as that 1/2 took up. So, he started with 1. Let's put it here, actually. And then he modeled his half of a fruit pizza. Then, he took 1/4 tiles. And he lined them up until he either matched it or was a little off. So he took 1/1/4 tile, just 1/1/4 tile match. Class?
No.
No. So then he took another. Do 2 1/4 tiles match? Class?
Yes.
Yes. So that means there are 2 1/4 tiles. Now, if there's 2 1/4 tiles, we write that fraction as 2/4. Because we have 1, 2 1/4 tiles. Now that means 1/2 and 2/4. That means 1/2 equals 2/4. So they are what? 1/2 and 2/4 are, Zari?
Equal.
What's the math word?
Equivalent.
Equivalent. Good. Now, 1/2 and 2/4 aren't the only equivalent fractions. Because maybe there's more than 4 people that want some of this pizza. Maybe there's 8 people. So, Noah took his 1/8 fraction tiles. I think I have 1/8. I hope I have 1/8. I might not. No, I didn't. He took his 1/8 tiles and he did the same thing as the 1/4 tiles. He started with 1. Are those equivalent? No. Definitely not. 2/8? Nope. 3/8?
Nope.
Nope. 4/8?
Yes.
Yes. So, he used 4 1/8 tiles. What does that fraction look like? 4 1/8 tiles. What does it look like? What's the numerator? Cullen?
4.
4. And the denominator? Lena?
8.
8. So that means 1/2 equals 2/4 equals 4/8. They are, Carla?
They are equivalent fractions.
They are equivalent fractions, which means half of the fruit pizza is the same as 2/4 or 4/8 of the pizza. That means he can take that half and he can cut it into 2 pieces that are each 1/4, but that's not enough for everybody to eat. So, or he can cut it into 4 pieces that are each 1/8. Now, the family of 4 can each have a piece. Let's test something. What if I wanted to see if I could cut it into fifths or thirds? Like, I want to see if I can cut it into thirds equally. Let's test. Is 1/3 equal? No. So I'm going to add another one. Uh-oh, what happened? What happened when I tried 2/3? Colin, have you gotten to answer? Yes, you just got to answer. Who hasn't gotten to answer yet that wants to answer? Victoria. What happens when I try 2/3?
I want to say it overlaps, like it goes too far.
It's too big. Because I only have this much pizza. So is it possible to cut the pizza into 2 pieces that are this side when I only have this much pizza? No, it's not. I can't cut it into another equal one this size because it's too big. There's not enough pizza. Very good. Okay, so keep that in mind. Not all fraction tiles will make equivalent fractions. What do you notice about the denominators of each of these, 1/2, 1/4, and 1/8? What do you notice about them? Mason? The denominators?
Oh.
They're all even. I wonder if that means any even number denominator, we'd end up being able to make an equivalent fraction. Let's try. Let's try with 6. With 1/6 tiles. 1/6. 2/6. 3/6.
Yes.
Let's keep it going. Let's try 1/10. 1/10? You can tell me out loud so I don't have to turn around. 2/10?
No.
3/10?
No.
How many tenths do you think it'll take to make an equivalent fraction? Mason? Let's see. Somebody have a different answer? Kingston? Let's see. Let's see who's right. So 3/10 is an equal. 4/10?
No.
5/10?
Yes.
Huh. So Kingston, you were right. Why did you think 5/10? Somebody who thought 5/10. Why did you think it was going to be 5/10? Colin?
Because when you keep putting one on, it keeps adding one.
Okay. But why did you think 5/10 and not 4/10? We were at 3/10. Why did you think 5/10 and not 4/10 or 6/10 or something else? Smith?
I thought it was 5/10 because I counted ahead a little bit to see if 5 1/10 or tiles could fit.
Does somebody have a different answer? Victoria?
I did 5 times 2
Why did you do 5 times 2?
because it equals 10.
Well, why did you think, what times 2 equals 10? That's how many. What led you to think that?
Because we were doing even numbers and I just started to do multiplication in my head.
Because look at 1/2. 1 times 2 equals what?
1 times 2 equals 2.
Let's look at 2/4. 2 times 2 equals what?
4.
4 times 2 equals what?
8.
We didn't write this, but 3/6. 3 times 2 equals what?
2.
So Victoria was on the right track for our lesson on Friday, where every time she knew it was going to be equivalent to 1/2, because if she multiplied the numerator by 2, she got the denominator. So she was on the right track. Keep that in mind for Friday's lesson, and a little bit tomorrow's. Okay, so does everybody understand how to use the fraction tiles to match? That's why you're cutting them apart, so that when you're at home, you can move one at a time. And you can move them all over the place. Like, you don't have to look at 1/2 and then go all the way down to the 12ths and see if they match. You can just put 1/2 down and then move 1/12 pieces right underneath it. That's why you're cutting them out. Okay, let's go ahead and move on to number 2. Helper number 1, please sanitize, erase, sanitize. Please be careful of the fraction tiles. I'm looking for everybody's finger or pencil. I'm looking for everybody's finger or pencil. Okay, if you're not with us, you just won't learn. It's up to you. Read in your head while I read out loud. Every period, we're going to stop and visualize. Quan's bookshelf has 3 shelves, okay? I'm going to draw a little picture. I'm imagining a bookshelf, and it has 3 shelves. Okay, got it. Only one of the shelves has books. Okay. I'm imagining just that shelf having books. Quan says 1/3 of the shelves have books. His mom says 2/6 of the shelves have books. Are they both correct? So what we're trying to see is we are going to use fraction tiles and then number lines to find if the fractions are equivalent. So first, I'm going to use number lines. I'm going to take my 1 whole fraction tile. I'm always going to start with my 1 whole fraction tile because I want to make sure the 2 fractions not only look the same but also take up the same part of the whole. First, Quan says that 1/3 is how much of the bookshelf is taken. So I'm going to take one of my 1/3 tiles and I'm going to line it up with my 1 whole. So there's Quan's. For his mom to also be correct, here her fraction has to match. It has to take up exactly the same amount of the whole as 1/3. So his mom says 2/6. So now I'm going to take my 1/6 tiles and I'm going to put 2 of them and line them up and see if 1/3 and 2/6 take up the same amount of space in the 1 whole. So Quan says 1/3. Quan's mom says 2/6. Are they both right? Yeah. Both of these fractions take up the same amount of space. They both take up 1/3 of the whole. So they are equivalent. Now, here's how we use number lines. We're not going to draw number lines because remember, do we draw number lines to compare numbers? No, because we can't be sure that we drew it exactly correctly. Maybe an artist could do it. A computer could do it. But we, with our hands, cannot do it. I mean, like a professional artist that's been doing it for years and years and years. And even they would probably struggle and wouldn't be 100% sure. So, another way is to use number lines. Here, we have our first number line that's broken into 3 pieces. We have 0, 1/3, 2/3, 3/3, or 1 whole. And we're going to plot Quan's number, 1/3. Next, we have a number line that's broken into 1, 2, 3, 4, 5, 6 pieces. We have 0, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, or 1 whole. And we're going to plot Quan's mom's fraction, 2/3. Now let's look at him. Can we draw an imaginary line? An imaginary straight line that goes right through both. Can we? So are they equal? Are they equivalent? Yes. 1/3 of 1 whole shares the same point on the number line as 2/6. 1/3 of 1 whole takes up the same amount of space as 2/6 of 1 whole. So they are both correct. 1/3 equals 2/6, so they are, Mason, equivalent fractions. Okay, so is everybody with me so far? Oops, just dropped that. I'll get it later. Is everybody with me so far? Victoria, quickly.
On 1/3 and 2/6, I realized that 1 times 3 equals 3, and then 3 times 2 equals 6.
So Victoria noticed something. Oh wait, sorry. Yeah, sorry. She noticed something. She noticed that 1 times 2 equals 2, and 3 times 2 equals 6. I bet that'll help her for the lesson on Friday. I bet that'll help her a lot for the lesson on Friday. And the fact that she shared this with everybody, if you're listening, it's going to help you a lot on Friday. And if you put it in your brain, instead of letting it go in one ear and out the other, it will help you on Friday. Okay. Is everybody ready for the guided practice? Okay. Good observation. Let's look at the guided practice. Number 1 says, complete the number sentence with an equivalent fraction. So we have 1/2 and we have 2 1/4 tiles. Are they the same? Actually, I'm going to pick a stick. Colin, are they the same? Are they taking up the exact same amount of space?
Yes.
Yes. We also can test with our fraction tiles by actually lining them up so there's no space between them. 1/2, 2 1/4 tiles. You can test them on your own. Do they still match?
Yes.
Yes. This way, if this little bit of space kind of throws you off and you're like, well, I'm not really sure, you can take your fraction tiles, smush them together, and see, are they still equivalent? So, we know this is 1/2, right? Because it's only one fraction tile. But 2 1/4 tiles, do I write it like this? No, that's a completely different fraction. That is not 2 1/4 tiles. This actually looks like this. So, do not write 2 1/4 tiles like this. How do we write 2 1/4 tiles? Colin?
We write 2/4.
So how do we write that? What's the numerator?
2.
2. And the denominator?
4.
4. So 1/2 is equal or equivalent to 2/4. I think I know what you're going to tell me. Does that work?
Yes.
Interesting. Do you think you can only use 2 though to multiply? We know this from earlier, right? We did that ourselves. Can you multiply 2 to get this? Can you multiply something else? Colin?
Yes. Times 3.
That's what I said.
Does that work? Does that work?
Yes.
Yeah. What about, we know this from example 1. Carla?
We multiply 1 times 4 and multiply 2 times 4.
Huh. Now, every time we've multiplied, did we multiply the numerator by a different number from the denominator, or did we multiply both by the same number? Colin?
Both by the same.
Both by the same number. Keep that in mind. Okay, I think you're ready for the guided practice, the independent practice. Let's go ahead and do numbers. No, you know what? I think you're ready. I think you're ready to just go for it. I don't think we need to do much. If you were listening and focusing, I think you're ready. So go ahead. We don't need as much time, so let's see, we have 15 minutes till reading is supposed to start, but I'll give you 10 extra minutes, so that's 25 minutes. Go ahead and begin. I will go ahead and do numbers 2. I'm not going to do number 4 because it's the only number line. Use your fraction tiles to help you. So right now, everybody get out your fraction tiles, your plastic ones. Or, Zari, if you have your paper ones cut out, you'll have to use those. Let's do number 6 together so that I can show you how to do that with fraction tiles. Number 6, the directions say match each pair of equivalent fractions. So we have 1/2, so I'm going to take my 1/2 and I'm going to model it. I have to match it to one of these. I see 1/8, 1/6, 1/8, and 1/4. So I'm going to get my 1/4 tiles, my 1/6 tiles, and my 1/8 tiles. That one. And then I'm going to start seeing if they match. I'm going to start with these two 1/8 tiles. Does that match? Do those match? 1/2 and 2/8. Do those match? No, definitely not. Look at all that space. Do those match? Oh. So, well, now I already have my 1/8, so let's try 1, 2, 3, 4/8. Do those match? Yes. So I know 1/2 matches 4/8. Let's test the 6ths and the 4ths to see and also to model how to do it. So here I have 1, 2, 3, 4, 6. So I'm going to see if they match. Does 1/2 and 4/6, are they equivalent? No, look at all this extra space. So I know that's not a match. Now let's try 1, 2, 3, 4ths. One, 2, 3/4. Do those match? Are they equivalent? Class? No. So that's how you use the fraction tiles. You create one fraction and then you line the rest up. These are going to match only one. So you're not going to have 2 lines or 3 lines or whatever coming from any of these numbers 6 through 9. Okay, go ahead. You're going to have about, let's see, you could have been working while we were doing that, so now you have 12 more minutes. No, wait. Hold on. 17 more minutes. Any questions? Carla? You can use the tiles. If it's already, like, everybody listen, numbers 2 through 5, you already have the models there and they're right next to each other, so you don't need the tiles. Numbers 6 through 9, since they're not right next to each other, if you want to make sure they match, go ahead and use the tiles. Numbers 10 and 11, well, model all those fractions with your tiles, see which ones match. Make sure that you're listening because you can be going over this and doing this. Numbers 12 through 14 are critical thinking with numbers and words. You may or may not need fraction tiles for those. Then look at your homework. Numbers 1 and 2, you already have models, so you won't need fraction tiles for those. Numbers 3 and 4, you also have models, so you don't need fraction tiles. Numbers 5 and 6, well, you can model all of those fractions using fraction tiles to see which ones match or which ones are equivalent. Number 7 is vocab. Number 8 you can test each of these options to see which ones are equivalent using your fraction tiles. Okay? Go ahead and begin.